Okay. So case 1 and case 2 are where you use law of sines. So there's 4 cases. So case 1 is when you have one side and 2 angles. Oh yeah. Sorry about that. That better? You have one side and 2 angles. So one side and 2 angles are known. We'll phrase it that way. The book calls that ASA or SAA. Make sure I don't spell the wrong word there. Case 2, you have 2 sides and an angle opposite to one of those sides. So 2 sides and an angle opposite to one of those sides. So this is when you use law of sine, case 1 or case 2. If you do not have one of these cases, you can't use law of sines, which you would have to use law of cosines, which is going to be case 3 and 4. But law of cosine is going to be saved for 8.2. But I'm going to give you the cases now. So here you have 2 sides and the angle we'll just say not opposite to those sides. That way it's clear, because the book calls it an included angle. And I'm like, well, what does that mean, right? Just rephrase it. Okay. Case 4. They give you 3 sides and no angles. So chapter 8.1, 2, and maybe 3 are just about solving triangles. So find the angles, find the sides, that's it. Those angles can be representing real life scenarios, like one side could be a distance between 2 objects, could be the height of a tree, could be, I don't know, there's a famous example, the 2 ships at sea, depending what's going on, which we'll probably do later. But anyway, so those triangles are important, solving all the sides, angles, etc. Right?
Which angle for case 4? 3 sides and 1 node angle?
Oh, I'm sorry. Wasn't paying attention to myself. 3 sides and no angles. This is called SSS. Side, side, side. Law of sines. So here's a rule. For a triangle, with sides ABC, lowercase, and opposite angles, capital ABC, respectively, actually. Okay. So some rando triangle. Call A, B, C, and then the opposite side would be lowercase b, lowercase a, lowercase c. So given some triangle and you want to find these sides, you use the following ratios. So I'm going to call this number 1. Sine A over little a is equal to sine B over little b, which is equal to sine C over little c. This one's, I would use this one for solve when you're trying to solve angles. So I use this for solving angles. Probably write that better somewhere else. Just a moment. So little a, it's basically the same formula. I'm just gonna take reciprocals. It's not really a new formula, as you can see. I'll write a note over here. Note. Use 1 to find angles. Use 2 to find sides. That will save you a little bit of algebra work. You don't have to. You can just stick with the same one over and over again, but I like to set this up first when I want to find a side. Okay. And I'll wait a sec. So that's all we need to start our examples. So we are no longer dealing with right triangles, because if we were, we could use Pythagorean theorem and definitions of the trig functions to find your angles, your sides, etc. So do not use Pythagorean theorem on chapter 8, right? Those are only for right angles. There are no right angles here. So we have no choice but to use law of sine or law of cosine. I lost my thought there. Example 1. So the homework's gonna be stuff like this. Either they'll give you the triangle or they'll give you information. And all you gotta do is solve the triangle. Excuse me. So I'm just gonna go ahead and draw it over here. I believe on this one they gave it to us. This is not the actual triangle, it's just because I can't draw. So they're gonna give us angle A of 60 degrees. Angle B is not given. Angle C is 100 degrees. Little c is 4. A is something, we don't have it. B is something.
Which problem is this, Professor? Sorry.
I don't know, actually.
Section 7.2.
It's 8.1. Chapter 8.1.
On 8.1.
I don't know. It might be the beginning or
Okay, thank you. Yeah, I know this doesn't give the numbers normal.
yeah. Usually I write some from the homework, but I don't remember if I did that this time. But I'll check in a little bit.
Okay, sorry for interrupting. Thank you.
Okay, so what I like to do is write down what I do have. We don't have B. We have little a, no, we don't. Little b, c. Now, you guys should all be able to solve for B, right? Capital B. What is capital B? What does it have to be? You see it? Right, the total needs to be 180. You got 160 so far, so this needs to be no choice, right? Okay. I'm gonna go ahead and box any answer that we find. That way I know later what was given and what wasn't. Now, I need to find 2 more sides. So you cannot use Pythagorean at all. I'm going to set this ratio equal to this guy and solve for it. So A over sine A is equal to C over sine C. So solve for little a, because that's what I want, right? I do it in general that way. You plug in the numbers at the end like a formula. Okay. You multiply both sides by sine A, you get to here. I'm going to show the step this time, but I'm not going to show it after a while. See what I mean? I'll just plug in everything and you'll have C. I recommend that you put your calculator in degrees because all of this is in degrees. We're gonna have this entire chapter is gonna require at least a scientific calculator. there. If you have a fraction button, go ahead and use it. If you don't, you're gonna have to pretend. I'm gonna pretend I don't have one. Top part put in parentheses. So I guess let's write the numbers down. C is 4 times sine of 60. That'll go on top over sine of 100. So 4 sine 60, parentheses for the top, divided by parentheses on the bottom. Looks like A is approximately 3, I'm gonna round to one decimal place, 3.5. Any questions on this first part? Okay. So just do the same thing now with this guy. So we'll call that step 1 here. Solving for A. Step 2, solve for B. E over sine B is equal to, now I can choose either ratio, C over sine C or A over sine A. Doesn't matter technically, use either one. But I'm gonna choose this one because this is what we were given, and there's been no rounding on these values. So I don't have to worry about any rounding error. So let's isolate little b, multiply both sides by sine b, and you're gonna get to here. So I'm gonna skip that minor step we did earlier. Plug in your values. And then use your calculator. Trying to find a non-glare spot, whatever. If you have a TI-84, you can do the fraction button and avoid the parentheses. If not, just do the parentheses like I showed you. It should be fine. So we solved the triangle. We've got all 3 angles and 3 sides. Any questions on number 1? Okay, let's move on then. Let me open the homework really quick. Just in case. Sign me in. Who signed me in? That's a question. Okay, we're still good. Okay. What the hell that was about? 8.1. So the first few questions are kind of testing you on the formulas. So who cares about that? Number 5 is similar to what we did. So what we did is, if you want to write a note at the go, I would just put example 1 is similar to problem 5 because we found an angle and 2 sides. Okay. Example 6 is different. Okay. Now, but I need to show you something before we get too deep into this. So when you're doing law of sines, well, I guess we should think about this. If you are given a picture of a triangle on your homework, like for example, they show it to you, right? Then obviously there exists one triangle, right? Because you can see it. I mean, I know that sounds weird, but think about it. Now, a question like this guy though, number 8, they don't actually show me the triangle. So there's a possibility that there could be, while you're trying to solve things or solve for sides and angles, there might be 2 triangles, 1 triangle, or no triangle. So I'm going to show you how to test. Like, all right, do I have 1? Do I have none? What's going on? Number 9, it turns out there is none, and you have to test and show why. Number 10, they have 2 actual triangles. Okay, so that's where we're headed. But it starts off pretty chill, like similar to what we just did. Okay, you guys cool in this page, right? Well, next example, even though I know there's probably only going to be 1 triangle, I'm going to go ahead and show you how to test. So example 2. Two sides and an angle are given, excuse me, are given. Determine if you have 1, 2, or no triangle. Trying to shorten it up a little bit. Shoot. I'm trying to remember what was given, what wasn't. I think that's all they gave us. So I need to find, well, they didn't tell us to solve. All they told us was determine if you have two, one, or no triangles. So let me show you how to do that. So basically what you do is try to solve for one of the angles and then test. So back in chapter 7, when we solved for solve trig equations, right, there was multiple solutions. So those two solutions could lead to two triangles. That's where we're headed. Okay, so I'll show you in just a sec. So set it up this way to find angle C. So sine B over B, sine C over C. Isolate sine C by multiplying both sides by little c. That gets you to here, right? It cancels. Now, in order to cancel sine, I need to do sine inverse of both sides. Which will cancel this guy. So now I have little c equal to sine inverse of c sine B over little b. So there's the solution. So just plug everything in and you're good. Okay, make sure you're in degrees though. So this will be sine inverse of 5 sine 140 over 7. Oh, wait a sec. All right, let's punch it in. So when you find the solution, you need to find, you're gonna have to find the second one by subtracting from 180. Second, sine inverse, let's use the fraction button, make it a little prettier. 5 sine 140 over 7. That's not 7. Okay. So potentially we have two triangles or none. I don't know. Let's see. So C1 is going to be 27.3 degrees. So we'll call that angle C of the first triangle, and C2 will call C2 is the other C from the other triangle, if it exists. But so what we did in chapter 7 was subtract from 180 to find the other solution. So basically you get both solutions like we did back then. And then check, I'm like, okay, do both of these work in this triangle? If both solutions work for when you add it to B, then that means you have two triangles. If only one of them works, then you only have one triangle. If neither of them work, then you probably have none. Okay. But usually the none scenario happens when you get an error. So you're trying to solve for B or something or C, and the calculator says error. You just stop right there. Say no solution and move on. Don't waste your time. But if you get a solution, you got to check both. So this is how you check. So you take the capital B and check, is B plus C1 less than 180? That's the question. Right. B plus C1 is equal to 140 plus 27.3, which is equal to 180, right? I just put it down here. No, sorry, that's not true. It's less than 180. It'll be 167.3, which is less than 180. So this tells us that B is, or C1 is fine. Okay. Cool. So now check, what about B plus C2? Is that less than 180? So B plus C2 is equal to 140 plus 150. So you see the problem, right? That's bigger than the angles of a triangle. So I can't use C2. So even though when you're solving for, whenever you do an inverse sine, you get two answers. And you find you get this one from the calculator, and you get this one by subtracting from 180. Even though they are technically solutions, they do not form a second triangle. So this is, what is that? $292. So since B plus C2 is not less than 180, then we have only one triangle. Okay. Does that make sense though? I mean, I'm trying to get that across, but it's a little weird the first time. So you find two angles, check if they both work. If both of them work, then you're basically going to create two separate problems. You're going to find another A and another B. Awesome. But this question was just to, all you needed to do is determine how many triangles. If we had an error, you would have said no triangle. If it both angles would have worked, you would have said two. But you only have one. That's all we're doing here. Okay. Any questions on example 2? Yeah. Good. Let's see here. Let's do this one on the homework. So this is an example where you have two triangles. So on the exam, I'm not going to tell you. You need to figure it out yourself. You need to check. But on the homework, it looks like they might tell. They might actually tell you. We'll see. I don't know. From my perspective, it looks like it. Anyway, example 3. use law of sines.
Can you switch screens, Professor?
Yeah, well, just a second. Let me just write the question down.
Thank you.
Let me try to shorten it up. Okay. This is what they gave us. I'm gonna try to draw this out so you can see why we potentially have multiple triangles. So A was 54. Think about this part. So let me give you a drawing here. So the reason why there's two triangles is when you solve for, let's say, when you do the cosine inverse of to find the b here. When you do that, you can have two different b's, and they're gonna both work. And the reason why that is I'm gonna put b up here just so you can see it better. So either b is gonna close off over here, or it's gonna close off over there. Okay. No. B. Shit. Try to give you a nice drawing, but give me a sec. It's this one. 54, 9.7. That's fine. Okay. Okay, so I'll just stick with it. So if I close it off over here, right, then the B has changed. It'll be over here, which then changes the C, right? It also changes the length of the B side. If it closes out here, so now we have a bigger triangle, and the angle would be wider. That makes sense? So basically you have a triangle that's over here, or one that's out there. That's, or picture like the triangle opening outward and then or inward. Yeah, like a flap, I guess. So that's the concept, okay? So solve for capital B. We we always said equal to something that has both the angle and its opposite side. Okay. So I'm choosing sine A over little a. Sine B is equal to B sine A over A. Sine inverse of sine B is equal to sine inverse of B sine A over A. So that gives us that B will be equal to sine inverse of B sine A over little a. So plug in all your numbers. The 11.4 sine of 54 over 9.7. So for the angle, we will round up to the nearest whole number. 72 degrees. Now, we're going to call this B1. Okay, so this is the first step was to solve for capital B. And then check if both work. So 180 minus 72 will give us, what is that? 108? Right? All right. That's one. Well, we're good. 108. So now check. If I add 54 to this and this one, are they both below 180? So let's test it, right? Even though we can see that when the writer is a note. B1 plus A is equal to 72 plus 54, which is equal to, what is that? 126, right? And then we do B2 plus A, which is going to be 108 plus 54. So they're both below 180, right? So since B1 plus A is less than 180, and B2 plus A is less than 180, then we have two triangles. Does it make sense how to check? That okay? All right, so we have two triangles. So let's call this guy B1, C1. Now this angle is not going to move, right? It's only the B that's going to move around. This one's kind of fixed, even though we could call A1 and whatever, but we don't have to. It'll be the same. Now, what's capital C1? Right? Subtract from 180. And we have almost one whole triangle. Okay, so I'm going to do more work on the back. Having two triangles is the worst case. It's the most work. No triangle is the best one because you don't have to do anything. The one triangle is pretty easy. You guys cool on this page? Let's go ahead and find C1. So once I do that, I'll have another triangle. So over here, I'm going to call this A, little a, B2, possibly B2, C2. Okay. What was the other B? 11.4? B2, capital B2. 108. And the original A was 54. Okay, so this one's not going to change. This one was the other solution, which will then change this one, right? So you can find C2, no problem. Little a will stay the same. This is triangle 2, by the way. Now, quick conceptual question here. This part that's moving in and outward, it's the same piece on a hinge. So I don't think that A will change, little a. The little a is just there, going in or out. So I believe that this guy should be the same. But let's look at our answer, see if we're on the right track. Right, let's see here. Yeah, the only thing that changes is the two B's and the C's. So our picture is legit. Okay. B does not change. Little b. So all we need to do is find C2 and C2. So 180 minus 54 minus 108 is 18. So find both C's and we're good. So using triangle 1, C1 over sine C1 is equal to A over sine A. So little c1 would be equal to A sine c1 over over what was it? Sine A. Plug all that in, we'll get 9.7 sine, what was C1? 54 oh shit, that's not right. Wait, is it? Oh, I see. I made a mistake. This should be 18. I don't know why I put 54. Right, 50 is 180 minus 72 minus 54. Oh yeah, it is 54. Oh, it just happened to be the same. Sorry. When I saw the same number, I assumed I was wrong, but never mind. Never mind. Just messing with my head. Sine A is 54, so that means that C2 is 9.7. Right, these are gone. Yeah. Okay. Sorry guys, I'm like a little scatterbrained today. This is C1. Triangle 1 is complete. Right? C1 was 7. Yeah. Strange. Okay. Anyway, I'm just obsessing. All right, so C2. So do the exact same thing. C2 over sine C2 is going to be equal to A over sine A. Solve for C2. So C2 would be equal to A sine C2 over sine A, which is 9.7 sine of 18 over sine of 54. So that's 3.71. Yeah, that's it. Those are two triangles. 3.71, that's right. Right here. 3.7 was the other one, etc. Okay. Any questions on this example? All right, let's do it where there's no triangle. So we did some that, we did two that had one, and then we did one that had two. This one's problem 9 from the homework. So we don't know how many triangles there are. All they gave us is A is equal to 100. No B or C. Little a is 175. Little b is 250. Little c is something. So when you look at this, you should know where to start, right? What angle should I solve for first by looking at this? Like, 'cause you're gonna create those ratios. You pick the wrong ratios, you're gonna have two unknowns. So I have to use, of course, these two, right? And equate it to either this ratio or that ratio. So I'm gonna choose this one because I have one of the answers, one of the pairs. So that's why I set it up like this. Sine B over B equal to sine A over A. Solve for sine B. Sine inverse of both sides. All right, plug it in. Capital B would be sine inverse of 250 sine of 100 over 175. So plug that into your calculator and you should see the problem. Or maybe you can see it now, I don't know. Remember the domain of sine inverse, right? You know, as soon as you try to plug it in, you're going to get an error. So this value is bigger than 1. So it's outside the domain. So there is no triangle. So as soon as you get an error, just stop. You're done. I would double check your work just in case it's legit. But if you see the error, you should be okay to move on. Conceptually, does it make, do you know what that looks like, having no triangle? Like, why does that happen? It sounds weird, right? Like earlier we explained when you had two, right? It was basically one side is shifting out or in, creating two different ones. Now, if you have no triangle, that means it just never closed off. Like it's too short. That makes sense. Like one of the sides doesn't go all the way. So you have two sides and then one side that just doesn't do it. It doesn't go and encompass the three angles. So something like this. Let's see, like, oh, just stops. Something weird. Or maybe I'll just go like that. So no traffic. Any questions on example 4? Okay. So let's use the rest of the time here. Try solving something on your own. So open your homework. Try to do 5 and 6. Because this is not going to sink in until you try to do it. Right, and right now it's fresh. So let's try and see if you can find some sides. Right, and I'll help you out.